All right, we have people coming in. Nicandro, hello. Howard, Stephen, Jeffrey, hello. All right, I did reset the router before the meeting, so I'm hoping that this would have helped a little bit. So far it seems like it is able to transmit data just fine, but let's see what happens. Yeah. Okay. Yeah, problem at work. Seems like an interesting challenge, Kandro. All right, we got 8 people so far. I think last time we had 40 plus. So we'll see how many people show up today. All right, James, how are you? Yeah, good. Yeah, it seems to be better today. We'll see what happens because it started out good and then it went kind of downhill for the beginning part. So hopefully this will be okay. All right, yeah, we'll just wait 1 more minute and then we'll just start with who we have. It might be a small class, it seems like. What's going on with Wednesday? Is everyone maybe feeling tired, or maybe the previous classes were too overwhelming? Maybe I lost a lot of people there. All right, just 1 more minute and we'll start. Who else is in the room? Yeah, microservice. It's anything to the extreme is kind of bad. When I think about microservice, there's a lot of similarity with microservice and OOP. Because OOP, the way that I like to think about OOP is basically the power to create folders. And the files, I think of features, like features for the project. So if you have like 10 features, you can really go overboard and create 1,000 folders and have 10 to store 10 files basically. And you can do the exact same thing with microservices where you can over-architect, and things that can really be built overnight, just for the sake, they create a microservice. It's almost like creating an entire new class just for the sake of the beauty of OOP. And I think the exact same thing can happen with the microservice, where you end up creating so many different microservices, and it's like, okay, I got 5 engineers and like 50 microservices to manage, and it just gets overwhelming, right? So I think as the class as we were talking about system design, I can see that happening. Just people like, oh yeah, that's the way to go. Cloud native technologies. Let's do Docker containers. Let's orchestrate these containers. Hey, can't we modularize that even further? And then one engineer is responsible for like 10 microservices, and then people just get sick. So I think it's very easy to make that mistake. So let's see. Yeah, Pramila, good to have you. Binyam, good. James. Antonina, hello. Steven? Yeah. 2 minutes early is the same as being hour early for a real meeting. Yeah, that's good. Yeah, Binyam, Jocelyn, Pamela. Okay, so it seems like we have a lot more people who have joined. Why don't we get started? All right, so yeah, it's, any of the refactoring takes longer. It's always better to do it right the first time, but it's easy to say, hard to actually do it. The cost of refactoring your code, converting, I think takes 3 times longer than doing it right the first time. Because not only you have to add features, you have to remove things that are not needed, and then you got to do more testing, easily 3 to 5 times more work to redo something than to do it right the first times. But I guess that kind of shows the importance of designing the system right the first time. Yeah, Samia, Jose, Stanley, DS, Alan, James, good to have you guys. It's good to have more people in the in the group. Okay, so let's get started. So today, we're gonna do something a little different than what we did yesterday. I did write up an article on the old notation, and then I also included the worst case scenario too. So let's see, the one that I published, over the last like week and a half. Oh, you're correct, Nicandro. Oh, what is that? Oh, okay. I think that was a comment that I made. Okay, so that's weird. Okay, so this one I wrote an article, and I think I posted this on Hacker Hero too, or on the Facebook group. So I have a summary chart. So we talked about the time complexity, average time complexity, but we can also look at the worst case time complexity too. So make sure you read this, and then I also created a takeaway. If you could take away, right? There's no way that you can remember all of this. I mean, there's just too much information here, right? So you do a read, but what are the takeaways? So I came up with 5 takeaways that I think are important. So just read it and, just remember some of these things, and I think you will be fine, right? I wouldn't memorize all of this. This just, our brain has more things to remember than, store big old notations for different data structures, right? So make sure you review that. Okay, make sure that you also start solving algorithms. I would say before tomorrow you should be almost. I mean, I'm hoping that by tomorrow, which is Thursday, you would have at least gone up halfway. That you're at least halfway on singly linked list. Right, that's kind of where you should be if you want to finish all of this by the end of the week. Right, you do have 2 weeks to finish it, so if that's the case, you should at least have finished recursions and sorting by now. Okay, if you haven't, spend tomorrow to catch up on some of this, and then I can see who has solved it, because I can go click on each one, click on the community, and see who tackled it. It seems like we only have about 10 people who solved the 6th problem on recursion. Okay, so we got what, 410 people signed up for the class, and only like 10 people finished the 6th problem on the advanced algorithm. We gotta speed things up. Okay, so make sure you do that too. But as we mentioned before, in the live class we'll talk about system design. Okay. Okay, I'm just looking over at the comments to see if I missed anything. I think everything is fine. Okay, so let's talk about system design a little bit. What we're gonna do is let's walk through some of the system design document for the exercise that we did on Monday, which was the image resample microservice. And let's do this. And then what we're gonna do as classes, you're gonna work on this challenge number 2, which is a drawing app. Right, so we'll walk this through, but after we kind of go over the document, maybe we'll spend 10-15 minutes. Then I'm gonna turn the time over to you, give you guys 20 to 30 minutes to use this program and see how you would architect this drawing app. Okay, so let's go through this drawing app. It's like a Google Doc, but you can draw stuff together with other people. So you can create a new room, right? If you click on create a new room, then it tells you, okay, it creates a random room with a number, and then you can start drawing stuff, and you can invite other people to this room, and they can start drawing stuff on here, and you can see what everyone else is drawing. So for example, if I'm drawing stuff and Joseph joins and then Maria joins, then they start drawing stuff and I can see it in real time. There's also a video. There's a scroll bar here, so I can go back and I can simply drag this to see how the drawings have changed in this room from the beginning. There's also a live chat. There is also an admin place where admin can see all the activities of all the rooms that ever existed, and admins need some fancy reports, some really fancy reports. And don't ask me why, but they anticipate the reports to be so fancy that they're gonna have multiple engineers, let's say 5+ backend engineers working on these reporting system for months. So majority of the application is gonna be very CRUD heavy, right? It's going to have a lot of engineers working on it for months, and it's going to do a lot of very complex queries. to generate these reports. So your goal is, okay, you need to find out what language framework would you use. Why did you pick that? Right? If someone asks you, hey, why did you pick that? You got to have a good answer, not like, oh, well, that's what I know, right? That's not good enough. You need to have a good answer. You need to tell me whether it's going to be a single service or multiple services. And if it is a multiple service, how many microservices you're going to have. You're also going to tell me where you're going to store the data, whether it's going to be a relational, non-relational, why, and you're going to design a database diagram too, if there is a need for it. Okay, and then you're going to tell me, are you going to use GitHub Flow or Git Flow? And then if you're going to have multiple microservices, throw me some names of what are some of the services that you're going to use, if any, to orchestrate your containers, or are you going to build all of that from scratch, right? That's an option too. But it always helps to know, throw some names and to let people know, hey, like I kind of know where to go and look for if we design multiple containers and we need to orchestrate them. Okay, so that's what you need to do, but not yet. For now, let's just kind of do a quick review on the first challenge, which is designing an image resize API. So I'm gonna let's kind of do a walkthrough on this, and I'll share some thoughts. If you do have questions, put it in the comment section so I can stop and I can take a look. Okay, now I'm gonna take a look and see what I need to do. Okay. Okay, it's good to have a lot of conversation here. The wireframes, I use Balsamiq. Balsamiq, that's one of my favorite tools. It's so easy to use and it's simple drag and drop, so it's Balsamiq. Yeah. Oh yeah, I see that Antonina, you already answered that. Yeah, I love Balsamiq. It's had as a free trial. I don't like the online one. I just bought a desktop one. I paid, I don't remember, 20 bucks or 40 bucks. It's just one time and I use it. It's a really, really good tool. And I bought it like 10 years ago. So it's a good use of $20 to use it, you know, for the last 10 years, creating a lot of different wireframes. It's really good. Okay, so let's go into this. So remember the image resize API? Remember the first thing, right? The story I shared is don't just jump in and architect the system, guys. Take a deep breath and be like, okay, you can say, give me a few minutes, let me think about this, and let me come up with some questions that I'm curious about, right? If you're going through interviews, take your time and ask them questions, okay? So if I'm understanding this correctly, you want to build an application that does X, Y, and Z. Is that correct? Right? And you can ask some, you know, some good questions. I won't go over these questions right now, but when we do your challenge, you can ask me questions before you start building the architect. Okay? So remember that key principle: listen before jumping in, ask lots of questions, research before jumping in. Okay? So let's imagine that we did all of that. Then let's say, do I need anything real time in this image resize API? I don't need anything anything in real time. So I go, no. Is this a weekend project? Well, that depends. Depends on your experience. But if you're familiar with some of the tools out there, yeah, this is a weekend project. This is a simple project. So then I would use a light framework. Would I use something like Django, which is heavyweight, or Rails, which is very heavyweight, or Spring? No way. It's too big. Why? It's almost like, to create 3 features or 3 files, do I really need a framework that has hundreds of folders? No way. I mean, just forget it. I'm just going to use a light framework, because this image resize API, if I think about it, I mean, how complex could this be? When it's simple, maybe 50 lines, maybe 100 lines. It's going to be very straightforward. It's a weekend project. So I'm not going to use some of the heavyweight, because one heavyweight framework slows me down when I build application. I have to, go in and create a controller, create a model, create migrations, like do all of this, set it up, and then this is too much work. Let's just use something very simple, such as Sinatra, Flask. If you're doing PHP, you can just do things in procedural on this one, because it's very lightweight. Why bring the complexity of an MVC framework when I don't really need? I mean, I'm going to have a single controller. I mean, do I really need an MVC framework? Absolutely not. So I would just use a light framework. How many engineers will be working on this? Man, I can build this, on the weekend myself, right? So speed or stability, that depends, right? If I said speed is more important, then I say, okay, does it need machine learning? I don't need any machine learning here, right? So there's no use of using Python and some of the libraries that are there for machine learning. If there was machine learning, I would say, okay, let's really consider using Python, right? Because we can leverage some of the libraries there. So we don't need any of it. So anyway, so it seems like we're just going to build something with very light framework. And it is going to be a microservice. Do I need any other microservices? I don't think so. I think one is just fine, right? Just one API. And then I look at the front end. Do I need this to be a single page? No way. No way. I mean, this is so simple, right? I mean, how many JavaScript file am I gonna give? Am I gonna give per HTTP request that the browser gets? Am I gonna send more than thousands of lines of JavaScript code? Absolutely not. There, if someone's ever using React or Angular or any of the JavaScript framework that's complex on this, it's like, what are you thinking? Right? There's no that much interactions on the JavaScript. So if someone says, oh, I'm going to use React for this one, I would be like, okay, why? Why do you even need React for this? And plus, I mean, there's not that much front end anyway, right? So I don't need any of the framework. So for me, if I was the interviewer, if you told me you're going to use Angular and React, I'll be like, okay, you don't understand why those frameworks should be used. Those frameworks are only if you have tons of developers working on it, and the JavaScript lines are going to be thousands of lines per HTTP request. If it is not going to be like that, it's almost like, again, you're building 3 features, and to organize those 3 features, you're creating 100 folders. Why? That's an overkill. That's over engineering, right? So that's really, really, really bad. Really bad. Okay, don't fall into that trap. Just because, oh, Angular is cool, React is cool, well, it's going to slow the system down. It's going to take longer to build things, right? My rule of thumb is if you build things in Angular or React or any of the heavy frameworks, it will probably take you 3 to 5 times longer, right? The value of those frameworks comes in when the application gets complex, not when the application is simple, okay? So anyway, these are my opinions, okay? I'm entitled to have my opinion. If you really like React, you may just use React for everything. I have some strong opinions about it. And again, these are my system design techniques after all. So I'm gonna go with what I think, okay? I'll stop here. Any questions you have, let me know on the comments, okay? Let me take a little bit of time because there is a 10-second lag, I think, from what I speak and when you guys see it. So let's, Rails is not light. Or maybe, is there another framework called Light Rail? I don't know. But Rails is so heavy. I have some strong opinions about Rails. Yeah. Ooh, do you know what? Let's talk about Rails a little bit. Rails is an awesome framework for experienced developers. But even for experienced developers, the trend right now is people moving away from Rails. That's my personal opinion. Okay, why is that? Well, I think there are a few reasons. One is, I think, everyone kind of jumped into the Rails wagon without really understanding how to use it. So they're causing a lot of inefficient queries with the active records or ORM available there. And then also, Rails is really good if you want to do things exactly the Rails way, one way. If you want to deviate from any of that, then it becomes super, super hard. So that's the second reason. Third reason is I think there are too many gems out there. It's very tempting just to use another gem and piece things together. Gems are really good to do exactly what the gem was built for. But whenever you need to customize anything off of the gem, it will take forever to customize the gem. And I've seen developers spend days trying to customize a gem when they could have just built everything from scratch in a single day. So that temptation is really strong. Fourth reason is Rails is very, very resource heavy. Node and Express doesn't take a lot of resource, right? It has pros and cons, but Rails consumes tons of CPU and RAM. I used to like Rails, so I had my developers build a bunch of applications in Rails, but the amount of CPU and RAM that the Rails server just needs is ridiculous. It's like 5 times more resource than what an Express server would need. So then basically you want to pay 5 times more just to use Rails when you can have built it in Express or like Flask? Okay, it depends on how much money you have, but 5 times could add up, right? 5,000 a month versus 1,000 a month, right? 50,000 a month versus 10,000 a month. That money could add up. So do I want to use a huge framework like Rails? I don't know, right? It makes me scared. And what if I get someone who's not an experienced developer, who's not really thinking about, the efficiencies of the queries, and they do things Rails, and they, nightmare, right? So anyway, those are some of my philosophies about Rails. I wrote an article on Medium about the danger of ORM. Whenever I think about a query, or am doing a query, I think of that as an O of N. Whenever and imagine you have a for loop and you're doing ORM to send a query. That's order of N square. Horrible, right? So I used to love I used to love ORM. Now I don't like it. I tell my engineers, don't ever use ORM unless it's a very simple thing. But just write the freaking SQL query so that you're not sending 1,000 queries to the database. Just send a single one. Some heated opinions, right? That came from experience, right? But people will be like, Michael, but no, it's not the right way. It's not like I want to do it the OOP way. I freaking don't care about OOP. I care about how fast we build things and whether it scales. I don't care whether you need to add 2 more lines of raw SQL query to get something done 10 times faster. Just get it done that way. Even if, in the Python Django ORM doesn't support that way, or Rails doesn't quite support that way, I don't care, right? We want to build things fast. We want to make it easy to maintain. So again, that's my personal opinion. Okay. So, yeah, and again, some strong opinions. It's okay to have opinions. Again, it's not that Rails is bad. There are some things in Rails that I super love. The way that they have done models, I think that has set an example to the rest of the world. And you can see how other people are like copying the Rails way. So I think they've done a good job on that. The TDD, some of the RSpec and Capybara, and how it ties in with Ruby and Rails, I think is really amazing. I just think it's too dangerous for people who are not experienced, who are not keeping an eye on efficiencies. And plus, even if that was all removed, Rails takes so much CPU and RAM that, I don't know. I like to save money. I guess because, okay, well, let's move on. Okay, so now I kind of picked, right? Now, whether I pick, Sinatra, whatever, I don't care. I will just go with whatever I feel like during the day, right? If I have done a lot of Python, I'll go with Python. If I have done some Ruby, I'll go with Sinatra. If I have done some PHP, I'm in the mood for PHP, I'll do some PHP work. That's fine. None of that really matters anyway, right? One of the things that may influence my decision is during the research phase, if I find out that, PHP has this library that it can leverage, then you can do that. But come on, something like the imagery size, you don't think every language would have that? Every single language has a library that does this, right? I guarantee it. If not, you can create it in like an hour. So most likely someone already created it and made it available. So, or it might already have been built in, right? So yeah, there's absolutely no difference what language you use, except if you were like, Michael, I'm going to build this in C++. I'm like, you kidding me? Why? Why are you building in C++? Like, what are you thinking? Are you going to build a whole operating system and a whole programming language with that? And then, build this? Okay, so that's the only thing, right? Okay, so how you would store the data? Any large file? Oh yeah, I'm going to have a large file. Don't please store that in the database. That's horrible. Horrible. Do not store large things, even though you can store that as blob or something else. Never store something big in the database, right? I would even say, like, if you're using MongoDB and you're storing a large JSON file, that you don't need to, go and parse through and, look at some of the inner details within the JSON data. You just need to retrieve it as a document. Do you want to store that in the database, or do you want to just store the URL and actually save that JSON as a text file in Amazon, right? Because unless you need to parse through the JSON file and do a lot of the computations and blah, 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 if you're just going to retrieve it once, just store it in a service like Amazon S3. Always keep your database really, really, really small. Do I need a relational, non-relational? It doesn't matter. On this one, it makes no difference because I'm storing one string, right? If I'm storing, or maybe 3 strings. So it absolutely makes no difference whether we use relational or non-relational on this one. So if I was an interviewer, I would be like, oh, why would you use MongoDB? Why would you use SQL? And if you said, no, something like this is good for non-relational only, I'll be like, okay, you're not leveled up yet. Because this one, in my mind, it makes absolutely no difference whether you store it in non-relational or relational, because it's so small anyway, right? It doesn't matter. It's more preference, right? And then, so now let's get some intuitions here, right? If it is 1 terabyte or less, again, it depends on the size of the hard drive, right? With a single server, how big is the hard drive? It keeps going up, right? It used to be that you get a hard drive. I mean, when I bought my first, my second or third computer when I was a kid, my dad bought it. It had 20 megabytes in my hard drive, and my friend was like, "Michael, that's so big. You can store so much in 20 megabytes." And I had 4 megabytes of RAM. And my friend was like, Michael, you will never use 4 megabytes of RAM. Can I have 2 megabytes? So anyway, that's back in the day. But how much information can you actually store? I think it's important to build an intuition around this. How many files or URLs do you think you can store in 1 terabyte? Okay, that would be kind of a good interview question. Put in the comments. How many URLs do you think you can store? And some other things like, when it was uploaded and, some other things, right? And we can do an orders of magnitude analysis. Do you think we can store 1,000 URL? Is it 10,000, 100,000, 1 million? Why don't you come up with a guess and put in the comments? Okay, I don't know the answer to this, but let's just do an intuitive check. Nikandra, this is the checklist for complete system design. It's a 5-page. You do step by step and you will see how my brain works. So this is it, Nikandra. This is the complete checklist. Okay, put in the comment section. How many URLs do you think I can store in 1 terabyte? That is kind of a good interview question. How come no one's submitting? URLs, no blobs. You're going to store it in S3, Amazon S3, and you're simply going to store the URL to the S3 bucket in your database. Okay, just put a guess. Just put a guess. How many URLs could you store in 1 terabyte? This is what makes this document really powerful, guys, because I never thought I could pass down what happens in my brain and intuition on 5-page. And I'm kind of sad that, oh my goodness, my years of system design experience was captured in this 5-page. Wow. I thought I was worth more than the piece of 5 pages. But anyway. Yeah, it depends on, make some assumptions about how you're going to store it, right? Again, how we store the file, it could be zipped, right, to make it smaller. But I'm not asking how much you can store in the Amazon S3. I'm asking that database where you're just simply storing the URL of the S3, right? How many records you can store. Make some educated guess on how big the URL needs to be. What do you think the URL needs to be? If you already know the Amazon S3 bucket, you just need to know the folder name and the file name. That's it, right? So probably 50 characters, maybe 35 characters would be enough to cover the URL, right? Because you don't need to store like amazon.com/s3/ your bucket name / blah, 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 right? Because all of that, so you don't need to store all of that repetitive information. You just need to store the folder name and the file name. That's it. Right, so probably I would say 50 characters is enough to store the URL. Maybe a little bit longer. You can go safe and say 100. Okay, 12.5 billion URLs. Okay. Yeah, thank you, Jocelyn. I do feel, yeah, I felt sad. I'm like, man, like my intuition was actually a process, diagram. And then I felt kind of like, what if I'm wrong? What if I'm, because I can't be an expert in all of these things, right? So what if someone who has way more years of experience comes and attacks my, philosophy? Ah, whatever. If they attack me, whatever. I think the gain that you get from seeing this 5-page is greater than personal attack I might be getting from, experts in the industry. Whatever. They can come to me, and then, they can teach me, and then I can modify the diagram and thank them, right? Okay, so Stephen, look at that, man. You actually did a calculation. All right, I like this. Right. So yeah, I don't know the answer to this. I mean, one easy way is, okay, well, create 100. I mean, you can go and you can do some estimation, right? So if it is 100 characters, let's say, and it's just alphanumeric, right? So it's just alphabet. So there are what, like 26 alphabet, and then include some other characters. So maybe let's say 35 characters. That it needs to support. So 35, oh man, this is now kind of getting into the weed of things. So how much character, okay, so let's just say one character takes how much bytes? Okay, one char type takes 1 byte of memory, 8 bits. Okay, so 1 byte of memory. So then if I have 100 character, that's 100 bytes, right? Now, byte. Okay, 1 byte. So my math might be wrong, but let's just do a rough order of magnitude. So 100 bytes. So then 1 terabyte is what? Oh my goodness, what is 1 terabyte? Terabyte. Okay, just Google it. There are 12 zeros. Okay, so, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divided by 100 that's like, okay, that's like, it's 10 billion. 10 billion. 10 billion! Around 10 billion. Okay, so Howard Choi. Yeah, but I may have done the math wrong, but it's a lot of numbers. I mean, so, do you think you're gonna have 10 billion people send you images? 10 billion probably is gonna be enough, right? So, it is enough. So, probably a single database will do. A single MySQL server will do. Right? You don't need something fancy. Now, this is assuming, I think you can even compress this down even further. Right? So you're storing, and I don't think you even need 100 characters. I think you can do it in 50. So 20 billion images. And then, do you need to store this permanently? I don't need to store it permanently. Maybe I delete it every 6 months or a year. So a single service, MySQL or Postgres, all of that will be fine, right? Do not ever use SQLite. I hate SQLite in production setting, right? When someone says, I know how to use SQLite, it's like, I know how to do additions. It's like, what? I need people who can do calculus, not people who knows how to do additions and subtraction. That's like how you should look at SQLite. It's a joke. It's good for testing and good for learning, but it should never use SQLite for production. It's horrible. So don't even write SQLite on the resume. I hate it when I see SQLite. It's like, what? You're putting in the resume, React, and then you know SQLite? What? It's like, why can't you just say, no, MySQL and Postgres? It's like the same thing, right? Okay, so anyway, we kind of sidetracked a little bit. If you need more than, let's say you need to store like 160 or 300 billion records, then okay, go in and use Amazon RDS. If you need to do more than that, okay, use Oracle. Oh, you need to even do more than that, okay, use Hadoop. This one is easy to shard too, so I can set up load balancers and have 10 databases. So I don't think you ever have to go into any of these options because you can just have one MySQL that has 10 billion, another MySQL that has another 10 billion, and so forth, and basically just set up a load balancer to distribute the traffic, right? Okay, does that make sense? All right. Yeah. All right, so that's that. And whatever you store in S3, you don't have to worry about it because you just pay for them, and Amazon will do all the scaling. Okay, choosing your testing. Yeah, okay, yeah, this is a weekend project. I'm just going to use GitHub Flow, right? And then I don't need continuous integration and delivery. Continuous integration delivery basically means tying your Git hooks so that when things are committed or when pull request is done, you set up code such as Jenkins so that it automatically deploys and runs test cases. If it ran, then it's like, okay, good job. If it didn't go, it says, hey, go back and fix your code and blah, blah, blah. You can read about it. Okay, this one, I'm going to have a single microservice. I don't need containers, or I don't need orchestration layer to manage one microservice, right? So none of this is needed. Okay, does that kind of make sense? All right, so you're getting some strong opinions from me on how things should be architected. Everyone would have different opinions. It's like, I'm talking about how to create the best car. Like, it's all subjective, it's all different. I have my opinions, someone else will have their opinions. Just learn from our opinions and you adopt your own. But I always say this, starting out with my opinion is not a bad place to start. It's not a bad place to start. You can be a lot worse than following someone not like me. I may not know everything, but some of this maybe need to be updated, but it's good enough to start, and it was certainly enough to impress your interviewer. So just use that as a starting point, and then once you get a lot better, then come and revise this flow for me. Okay. All right. Okay. Any questions? Give me some comments. I talked more than I wanted to, but I hope that was beneficial. Now is your turn. I'm going to give you guys 20 minutes to design this. So everyone go to hackerhero.com, and then you will see the problem statement, the app that you want to create. Everyone read it right now. Next 5 minutes, ask me questions directly in the live chat. Come up with questions. Just get comfortable with asking me questions. Okay? Come up with a lot of questions. Oh, someone already posted. Angel posted something. Good, good. Okay, don't look at what Angel wrote. Okay, you guys do your own work. And then I do expect by the end of the class, I want every one of you to submit your written answer as a comment at Hacker Hero. Okay, so that's what you need to do. I gotta hold you accountable. Okay, all right. So now read it. It's Hacker Hero Challenge 2 Drawing App System Design. Ask me question from now to the next 5 minutes. Yeah, this is available. It's also in the previous, where I walk through this in detail. It's a 40-minute video, and I even have a Medium article where you can actually see the flow. All of it is in Hacker Hero System Design. I designed Hacker Hero to be your buddy. Really reference it. It will help you a lot. Okay, so ask me questions. Are there going to be any kind of user accounts at all? Nah. Other than admins. Yeah, so admins will need to have accounts, right? Because you don't want to give everyone admin access, right? So you need to authenticate and have some type of a login system there. Okay, will we use HTML Canvas? I don't care. You tell me whether you're going to use Canvas or something else. Okay, what type of data are we looking for? On the report section, think of just, at this point, just think of everything. Like, I want to know on a daily basis how many rooms have been created, how many users, came in. I want to see, how long they stayed on, each page. I want to look at what colors they're using, what brush stroke they're using, who their friends are, who they talk to, blah, blah, blah. Just imagine all types of weird reports, and you need to generate all of that for the admin. And in fact, that's kind of the big portion of this project. Okay. The link is in the system. Okay, yeah. Can we have a for-hire chat service? No, you're going to create your own. Yeah, good question. Can you use a third party? No, you can't. You need to build everything from scratch. Just for the sake, just to see if you can do it, right? Okay, how many users are we expecting to use this application? A lot. Let's say 100,000. It needs to support up to 100,000 concurrent users. And you need to tell me if I want to support 1 million concurrent users, what you would do. So your microservice needs to scale up and down based on the volume. But a single microservice, a single server, I would expect it to handle a lot of concurrent users. Is there a limit on how many users can be in an individual room? Let's say, that's a good question. Let's say up to 200 people can join the room. I just made that up. Okay. Can we buy front-end modules such as material design templates? Whatever. You can use whatever you want. It's okay. Yep, good question. Howard, what will be the average size of the recorded video? Oh, well, that's up to you. Some will be really big, right? Because they will be drawing forever. Some will just be very short. So you need to figure out how you're going to manage that and how you're going to store that information. And if you're going to compress any of it, right? What will be the average traffic per month? So for right now, assume that you're going to get several million people visiting your site every day. Okay, is it required to be actual video playback or is it an iframe? You can just make it look like a video playback. It doesn't have to be an actual MP4 or movie file play. It just needs to have like the slider where I can go and kind of see, right? Okay, good question. I like this. See, whenever you ask questions, it makes you look smarter, which is good, right? You want to look smart. And it also buys you time, right? Kind of you start understanding the application more. Okay, Steven, if you wanted to create an Apple from scratch, first create the universe. Okay, I think that was more of a comment, not a question. Okay, what kind of rights do admins have versus users? So users can draw and stuff, but admins have their own dashboard where they can log in and see tons of complex, let's say useless reports, but to them it's not useless. And that there are like hundreds of pages that admins have access for some reason about what people are doing. It's almost like they're a big brother on the back, like spying on people. Yeah. How large will the images be? Well, you guys will have to try to make it as small as possible. So a good interview question is, how are you going to store the image? Or is it going to be an image? Right? How do you manage that so that it doesn't get too big? Okay. Limit to the number of rooms supported one time? No limit. Infinite. Is a drawing thing like a curve collection, like paint or editable object? Have it be whatever you want. You can have it be a vector so they can change it. Well, that might be too hard. Just have it be like pixels, like paint, right? Not like an editable object. That would be too complex. But great questions, because if I said, James, that's a great question. I'm glad you asked that. I wasn't thinking about that. It definitely made you look smart to me because I didn't even think about that. So that question was very, very neat because depending on the answer to that, your application does get very complex. So good job, James, for asking that question. Andrew, reports required to be interactive, dynamic, or static display. Some will be static, some will be interactive. Just imagine that admin dashboard, if you're one of the engineers working on the admin dashboard, your life will be miserable for years because you're thinking, how are these reports supposed to add any value in the world? But you're expected to work on those reports for years with 5 to 10 other engineers. It's a nightmare. It's like, okay, so we got one guy managing what the users are doing and we got guys working on the backend reports for the admin, but I'm intentionally creating that hypothetical scenario because a lot of times you may actually run into situations like that. Okay, I'll answer some of these questions now, and then after that, you guys need to jump in and start spitting out answers, okay? Requires, let's see, Nikandra, would you require the report sent by email on demand? No. TJ, which is more important, reliability or availability? Reliability is way more important for this. Does the drawing end at one point, like everyone leaves the room? Yes, good question, great question, okay? Michael Tran, what's the refresh polling rate for the home screen? Do we want infinite scroll or pagination? Yeah, infinite scroll pagination is fine, let's do it. Refresh rate? Every 1 second is fine. Okay, sounds good. So great questions, guys. I'm really happy that you asked a lot of questions because before it was like dead silence and I got 3 questions asked in 5 minutes. Now I think I got like 30 questions asked. This is what you should do. Ask a lot of questions, right? Repeat, like, okay, so if I'm understanding this right, you want something like X, Y, and Z. What sort of logging do you need? Whatever you think is needed. Log everything that you think could be useful for the admins to spy on people. Okay, all right. All right. So now with what you have said, that's plenty of time. 20 minutes. Go over this system design. the way, I think there was a link. If I, hold on, let me find out a link, because you can download this too. I put it in a SlideShare, and then I don't know if I like that SlideShare. So here I have public drive, and then there's a system design link. Let me just share this. So you guys can go to this link and just download the PDF too. Go ahead and do that. That might be easier, right? Download the PDF, start from this, giving it 20 minutes, okay? Go through this one by one, and then tell me what programming language you would use, what framework you would use, how you would store the database. Is that one microservice? Is that going to be multiple microservices? And then just go through. I want you guys to get comfortable with this process flow, so that more that you apply, you internalize the principles. Okay, go, 20 minutes. Good luck. Okay, so since I'm gonna be gone, I might as well just disappear and come back in 20 minutes. Okay, so I'm gonna be gone. It's your time, it's your homework time. And how many users? We got 26 users, a lot less than yesterday. I think I did scare people off, but it's their loss. I think you guys being here in the room, you will get a lot out of it. Okay, so go ahead and do that now. I will be back in 20 minutes. I'm not gonna end the stream. I'm just gonna walk out and play with my kids a little bit and come back. Okay, maybe I'll come back in like 15 minutes. Okay, good luck. Have fun. All right, I am back. Did you guys miss me? Correct, Andrew. Yeah. So Howard, multiple containers is not multiple servers. The video will explain, but I'll cover that in class. Okay. Yeah, because your phone's fine. Phone's fine. You can do Excel. My team does Excel. You just color code it different ways and do arrows. You could use MySQL Workbench. They have a nice ERD, but MySQL Workbench is going downhill. It's so buggy. It crashes all the time. So we just use Excel now. Yeah, the diagram has a lot of information. It's like 12 years of my knowledge. Like it's almost like I feel like I'm being naked, like giving away my secret know-hows to you guys for free, right? Not charging anything, but you guys are my students, so I want you guys to succeed. So it's okay, but so I'm not complaining, but it just felt weird. Like, wow, like, what I thought was my intuition, comes in these 5 pages? Really? This is it? I thought my brain worked more complex than this. But I was wrong. My brain was just following certain logic, and I wanted to believe it was intuition. Not quite. That's not quite the right answer either. Containers are not where it allows you to run multiple servers. No, it's not. Yeah, 20 minutes is not enough, right? Yeah, I know. Like, I mean, would you really architect the system in 20 minutes? Okay, so why don't we do this? I'm going to give you guys some time. I do think this is a good exercise, not something you want to rush, right? But as you get better, right? So we're going to do one today, right? You started it. Maybe you finish it. After our live class. So why don't you guys put a pause? If you're ready, go ahead and post your answer on the Hacker Hero. I don't mind. But if you feel like you need more time, totally understandable. This is your first time, taking an exclusive look at my brain. So I'm glad that, what took me 12 years can't be digested in 20 minutes. So, take time to do it, but do finish it. I do want every single one of you to finish it and post your answer in the next 2 hours, right? But let's take a pause and let's talk about containers, because I think there's a lot of questions about what containers are. Okay, let me explain this a little bit, and okay, let's see if this helps. Okay. So what is a container? Okay, let's first talk about what a typical traditional server is. Right? Oh, my Apple Pencil doesn't work anymore. I have to do it with my finger. Okay, so traditional web server, right, is basically just a computer, but there is an operating system. Right? Remember when you in the Dojo, when you set up a cloud server, it says, hey, do you want an Ubuntu server, a CentOS server, or a blah blah blah? There are many different choices, or Windows. And don't go with Windows Server, go with the Linux. But you get an operating system, you install it, you add all these dependencies, all these other programs, and then you put your code, right? How big is your operating system? How much RAM does it take? A lot of RAM, a lot of disk, right? And then you install dependencies. Have you noticed how sometimes your code works on your computer, but your code doesn't work on someone else's computer, and it's frustrating, right? It works fine on your Windows, but it doesn't work on PC, or it works fine on your Mac version 10.2, but it doesn't work on version 9.7. Super, super, super frustrating. So back in the day, you had people to manage all of these, and this is what DevOps did, right? So if you needed multiple servers, right, each server has an operating system, dependencies, and code, right? And then, as you're scaling up the server, imagine this is the web server, right? So I have a load balancer, and I distribute it, and so forth. And every single instance or server that you are scaling had an operating system. All of this is a single microservice. You can almost think of it as multiple servers, or maybe a better way is one service has many servers, right? And then one orchestration layer manages multiple services. So think of service as a collection of multiple servers, right, that are doing same thing, right? So maybe this microservice is, capturing what the people are drawing, right? And when one server is not enough, you have to, scale to multiple servers and so forth. That's still called a microservice. So when you zoom into the microservice, yeah, you may find one server, or you may see hundreds of servers. That's still one microservice. You may have multiple microservices that communicate with each other. So inside this, there are a bunch of servers, bunch of servers, bunch of servers. That's how people did back in the day. But now with a container, you don't need any of this. You don't need dependencies. You don't need operating system. They removed that out of the picture and they called it into a container. So now you just have to deploy a container and you don't have to worry about the operating system or the dependencies. In a nutshell, that's what Docker is. And it works, right? So if you're deploying something, before you just had to copy and paste your code to your computer. If you're using Docker, for example, where you actually deploy your container. So the way to work on it is more complex. There are more things that you have to do in the terminal, but you don't have to worry about, which versions of Mac OS are you using? You're using PC, Microsoft version, blah, blah, blah. You have these dependencies that have conflict with blah, blah, blah. You don't have to worry about any of that stuff with containers. So it's really nice. The downside is it takes a lot longer for you to set it up. So there is even a learning curve. And what used to be the responsibilities of the DevOps, now software engineers have to do it. So it's like, okay, oh my goodness, software engineers not only have to do all of that stuff, now all the things that, dedicated DevOps people had to do, now software engineers have to do that. Just like software engineers before, they could just write code and QAs were doing all the testing. Now engineers have to write the test cases. You can see the expectations for a software engineer is going larger and larger and larger. So anyway, that's what Docker is. Docker is just a containerization service. Just imagine a single server you can find in a microservice, just replace it with the container. So now instead of tools to orchestrate, right? So you can imagine there are tools to orchestrate servers here, right? Within the microservice, right? There are tools to manage microservices, right? Two different things. So for example, some of the, I have to look at this. So Kubernetes, I think is a tool to orchestrate, different containers, but not a tool to orchestrate different microservices. I think, tools like Rancher and, Amazon have these other orchestration service where you're managing microservices. But, so, it gets a little bit more complex. Watch my video and it will make a lot more sense. Okay. Different deployment, so these are mainly it. The deployment options are now, the trend is going into containerization. Create a microservice, put it into a container, and then, either you build the services to manage all these containers, which has a high learning curve, but now almost every single major cloud services offer these tools to help you manage multiple containers within the microservice. And they also provide tools for you to manage multiple microservices. That's kind of beyond the scope of what we need to do. That's pretty complex. So I don't think they're going to ask you to do that in the interview. And quite frankly, a lot of that technology is new. It's becoming popular in the last few years, although that technology existed for a while. So, I don't know all of that stuff. I have to ask my engineers, right? And be like, okay, what are the tools that you guys are using? What are some of the new tools? So just understand kind of at a high level how it works. And watch my video, but exactly what you type and things, don't worry too much about it until you have to design it. Then watch my video really carefully, and then figure out how to implement each step of the way. Okay. So Kubernetes is container management. So you have to just kind of remember what are the services to manage different containers or servers, right? So it's almost like, now it's like the way that I look at it is like, okay, so there are two different ways, right? You can launch things with servers traditionally. So, okay, I have a microservice of servers, right? So now you need all these tools to manage it within the microservice. And you also need another tool to manage all these microservices too. And then you got all containers method. And then these are containers now, and you need tools to orchestrate or manage these containers. And then you need another tools to manage these microservices. And then every single one they come up with a new name. So Amazon doesn't, they came up with their own new ways, and they came up with like 20 different technologies, orchestration, for this one and that one. Elastic Beanstalk is, for example, is one of these. And then they have Amazon ECS for this. And then Microsoft came up with another name and said, I'm going to do this. And then, Rackspace comes up with another one. And then another service comes up with another one. And then people start writing all these orchestration layers on top and say, oh, let's charge people for this. Launch it as a platform, as a service. And then, come up with their own new names. Everyone comes up with name. I don't know what the deal is with the software space. But they create their own software layer and they come up with a new name and confuses everyone. It's kind of frustrating. Just the sheer amount of volume that we just have to kind of get fed up with, that all these buzzwords. But again, go down to the principle. Okay, is it managing containers or is it managing microservices? Okay, it's not using containers, so it's traditional servers. Okay, I get it. Okay, so is this managing with a service, or is it managing multiple microservices? Right, that's all you have to know. It either fits inside this smaller bucket, or it depends, it's managing these groups of microservices. That's all you have to know. Okay. Does one container manage multiple microservices? No. Container is like a server, like a single server. Okay. But remember, all these services, that manage these microservices are another server, right? So if you look inside, there's a server or a container, right? So in a way, you can say a container is used to manage containers, just like a computer is used to manage computers, right? So anyway, but look at the high level picture, and whenever you are studying a new tool, just understand, is it managing all the containers within the same microservice, or is it a tool to manage multiple microservices, right? And I think that distinction will be helpful. Okay, and I see that some of you have experience with this, so you're adding comments in the chat. I appreciate that. It's really nice. It's really nice to see our alumni, you guys doing well, succeeding, doing good work as engineers. That makes me feel very proud. So just from some of the comments and the questions that you're asking, I can really tell that you've leveled up quite a bit from the time that you graduated. And so proud of what you guys are doing in the world, what you're creating, and the fact that you guys are wanting to constantly improve and get better and show up in this class at 6 p.m., 7 p.m., 8, 9 p.m., depending on where you are. So proud of you. So good job for staying active, learning, and growing. Really, really proud of that. Okay. All right. So I think sometimes just knowing these words help, right? Because the worst thing is you talk to someone and they throw out a buzzword and you're like, I never heard of it, right? It's like you go to do an interview and they throw out a name and you're like, what is that, right? Even if you don't know how to do it, at least knowing kind of how things fit in kind of gives you an advantage, right? So watch all my videos before you go do interviews, and I think you will be a lot better prepared to answer system design, especially when you finish doing the drawing app and when we do Hacker Hero. That's tomorrow you're going to design Hacker Hero. Hacker Hero took me a year and a half to build. It looks simple right now, but the video replay that we capture wasn't easy. Right? There are other things. Hacker Hero can actually support all the different programming languages, but I didn't have time, so I only started out with JavaScript. But it does have a microservice where I can run any programming language in the world. But that's overwhelming, so I said, let's just go with JavaScript and Python for now. But it does have. I built this so that it supports all of those. It also has what I call a level 2 editor, which is you can imagine I can launch a new instance. A new server is actually I launch a new container. So imagine I can launch a Rails app or Django app all directly from the challenge, and it shows up the editor on the left side, and it gives you full control over the server. So you do whatever you want in the server, and I record every single thing you're doing and create a video playback, because I wanted to break that myth that, you know, good software engineers, you feel like, oh, it's magical. You go to Stack Overflow, you see the final output, but you never see it. There's no platform where you can see the journey that the developers took to go from, you know, point A to point B. So I wanted to create a platform so that you can see how other people actually build things, and you can learn from them, learn from their flow, right? So Hacker Hero supports all of that. What you're seeing is what I call a level 1 editor, which is, function and stuff. But a level 2 editor that the team has worked on is where we can launch a new container from scratch, where you have full control over the server, right? We had to make it secure. You can create new files, new folders, you can run server commands, and we record every single thing you're doing, and we're able to do a video playback. So tomorrow you're going to design it, or at least you're gonna go through this flow and think about how would you build something like that if you were in my team a year and a half ago, and I told you I want you to build a platform that does X, Y, and Z. Okay, I will tell you that Hacker Hero is not built using one microservice. There are many, and there are a lot of real-time components, and there are some things like I talked about, like how do you create a virtual environment on the editor here, where people can write code, and you know, they can install gems, they can install new libraries, packages, delete files, delete folders, and still do it where it's secure. And all of that wouldn't have been possible if I didn't have Docker. But because I'm using Docker and containers, right, I don't have to have all that heavy system. So I create, basically, when someone wants to work on Django and Hacker Hero version 2, right, I launch a new instance, a new container with the Django environment, and you have full control over that container. So you can delete stuff, install whatever you want, right, and then basically build a UI layer on top so that you can interact with that server without remotely logging in. Although you could remotely log in to that server as well, right? So that's what we'll do tomorrow, okay? All right, so I think we're done. Let's not call it a cheat. Yeah, it's kind of a cheat sheet, but I don't like you guys to cheat. It's you can call me like Michael Choi's wisdom 5 pages cheat, but we don't cheat. We're legitimate, right? So but I understand why you called it a cheat sheet, but let's try to avoid that word, right? Because we're not cheating. You guys are not cheating. You're just benefiting from my wisdom, right? And you guys will ace all these interviews. And also, you know, create better system design. Okay, so I think I'm done. Let me know if you have any questions. Give me some feedback before you leave on what were some of your takeaway, and make sure you commit. I want to see every single one of you post your answer on Hacker Hero, on that challenge, how you would architect the system. Okay, so now I'll wait, and holy grail of system design. All right, you can call that. Yeah, Nikanjira, I'll take that. Yeah, but always remember, on the first day I said, you know, one of the best thing with the interview is it's not necessarily what you know, it's your attitude. You know, show enthusiasm. Enthusiasm is so important. Ask questions with a smile and be excited. Okay, so, you know, like, just be yourself. You can chill. Like, no one knows how to design any of these from scratch. Slow down, ask questions, you know, joke, laugh, and even if you don't get it right, you know, be a good attitude, and, you know, be enthusiastic. I know sometimes that's hard when you're like bombing the interview, but assuming you're not totally bombing it, right? Just, you know, being enthusiastic will go a long way. Right, the attitude goes a long way. Okay, all right. So yeah, throw some comments at me, and I'll see you guys tomorrow. Okay, I'll wait here another 5 minutes and to answer any questions you guys may have. Okay, do your homework. Do the advanced algorithms, guys. I spent a lot of time building this, so I want you guys to benefit. You will learn a lot from doing this. Okay, yeah. Take some beer. Yeah. Whatever, you guys are adults. You're not in the school. So let's see, let me go. Some system interview topic online discussed about calculating CPU RAM storage based on traffic. What? That's weird. I don't think that's normal. Calculating CPU RAM storage based on traffic. Yeah, I mean, you can do some like rough calculations, right? Okay, well, that's weird. I wouldn't ask that, but I mean, if you look at the functions, right, you can kind of see how much space your variable would be occupying, especially if you're building things in Java or C#, where it's strongly typed, where you have to define the variable type as well as the array. So if you're doing that, I can see that ties in with RAM, storage. I mean, we did some storage things, right? So we did some of that too. But CPU usage, I think that's more of the time complexity. So I think the big O notation time complexity is linearly dependent on the CPU, right? So one way to think about it is you are doing it, right? The big O notation is directly related to the CPU usage, right? And then the RAM is how many variables is the disk complexity, the memory complexity, big O notation, and storage. You've already done that. So I think if you look at a high level like that, we did cover that, but we didn't say what percentage of CPU is that going to use. Well, tell me how big of a CPU you're using, right? So that one is a little bit weird, but if you look at the high picture, we've been doing that too, right? How do we build algorithm in a way that does things faster, right? Which basically means consumes less CPU, right? How do we do things without creating bunch of huge variables and arrays? That's RAM. Storage, we talked about database design, right? Which is ultimately trying to reduce the storage based on traffic and data size, right? So we did cover that too. Yeah, it's okay. Just be yourself. If you talk a lot, Nikanjo, it's okay. Just be yourself. I think it's okay to talk, right? The most issue is for people who are too quiet. They're too shy. And it's hard for the interviewer to know what are they thinking. It's much better to be vocal, enthusiastic. Admit, okay, I don't know the answer to this, but this is something that I would look up later. So that's good. Okay, some are calling a Y stack developer as deploying Y stack developers, huh? Yeah, that's interesting. Yeah, I haven't heard that term. But yeah, the expectation for what they're expecting a software engineer to do, it's just going up and up and up. Before, like, you knew a little bit of HTML and CSS and some code, and because application wasn't that complex. But as applications are getting more complex, they want us to do DevOps work. They want us to do QA work. It's just like, and they all these new frameworks that are popping up everywhere, and all these new versions that are popping up. They want us to like maintain that and like remember it. It's like, come on, like it's a joke. Sometimes just the high expectations that are put on some of the engineers, but not everyone's like that, right? So and a lot of times hiring managers who are not engineers themselves, they don't quite know, right, what to look for, so they just ask some questions. Okay, so I think that's it. Thank you everyone for staying. Yeah, I'll see you guys tomorrow. Okay, do your homework. Bye. Good night.